Hi everyone, this is Mr. Kong. This is my chemistry revision series on qualitative analysis. Now we'll look at what QA is at the first start, and we'll look through the various tests for cations, anions, and gases. We will also spend some time to look at the various tests for an oxidizing and a reducing agent. And what exactly is QA? Now, QA is really a series of tests that we perform in order to help us to identify the cations, the anions, or maybe gases that are produced and the nature of a particular substance, such as a reducing or an oxidizing agent. And these gases these tests are usually performed on a particular unknown sample, which we have to identify. Now, for the first kind of test, which is the test for cations, we use one of two things, either aqueous sodium hydroxide or aqueous ammonia. And what we can expect to see will be things like a precipitate that is formed, and it can be a white precipitate or a colored solid, and whether this precipitate is soluble in excess. Now, what is this precipitate all about? Now, this precipitate are actually metal hydroxides because when we have the cations in the solution, these cations will react with the hydroxide ions from NaOH or aqueous ammonia to form the metal hydroxides that we see as precipitates. And this is the whole table which gives you information about all the various cations that are available in our syllabus and the effect of the NaOH and aqueous ammonia. Now, you might notice that aluminium and lead-2 give us exactly the same kind of results. And what is a way to differentiate between the two kinds of ions? Now, this is additional. And in order to differentiate between these two ions, we add a solution that contains chloride ions. For example, hydrochloric acid or even sodium chloride. And the reason is because the chloride ions will form a precipitate with the lead-2 ions, and it gives the appearance of a white-colored precipitate. However, with aluminum ions, although aluminum chloride is formed, it is soluble and it will not form any kind of precipitate. Therefore, this is the best way to differentiate between the two cations. Now, for anions, there are two categories whereby one forms a precipitate and the other kind of test will form a particular gas that we have to identify as well. Now, this table summarizes everything that you need to know for anions, and you realize that the tests for anions are quite different from the tests for cations. In a sense, you're using various kinds of reagents or chemicals. Unlike in cations, you only use two kinds of chemicals, sodium hydroxide as well as aqueous ammonia. And you notice that there are gases that are being produced, and this brings us to the next part where we want to test for gases. And some reactions that will produce gases include heating a sample or perhaps even adding acid or an alkali to an unknown sample. And these are all the gases that you will have to know. And in particular, one rather special gas is the last one, sulfur dioxide. You realize it decolorizes the purple acidified potassium manganate 7. And this is because it has some additional properties, which brings us to the next portion about reducing and oxidizing agents. Now, when we test for a reducing agent, we use an oxidizing agent such as acidified potassium manganate 7. And when we can see the color change from purple color to a colorless solution, it means that the sample is a reducing agent. Now, if you think back to sulfur dioxide just now, which does exactly this, it changes the purple color of potassium manganate 7 to from purple to colorless. It means that sulfur dioxide is indeed a reducing agent. Now, when we want to test for an oxidizing agent, we do something else. We add in potassium iodide, Ki, and if the color changes from colorless to brown, it tells us that that particular sample is an oxidizing agent. And there are some important colors that are shown here, but not to worry. There are three important colors that are really featured predominantly in our syllabus, and these three colors are green, reddish brown, and blue. And the ions that are responsible are also shown here. And this brings us to the end of this particular segment. Thank you